Video here on volume and area AP style. What that means is that we're going to be dealing with questions with what we've been learning recently about volume and area, and it's literally an FRQ question. So we're going to go through an FRQ here, just 3 parts, talk about it, go through how the grading would be, and yeah. So for this problem right here, we have our prompt is let f and g be functions defined by f of x, g of x, blah, blah, blah. R and S be 2 regions, which are right here, enclosed by the graphs as shown. Faraday wants us to find the sum of these regions. So to find these sums of these regions, we have to go ahead and integrate. So whatever the top here is to the bottom there, that's R, and then S is going to be whatever the top is there to the bottom there. So it didn't label for me which one's which, so I'm going to go ahead and graph these in my calculator. This would be a calculator active problem. So let's go into my y equals. Oh, this calculator is thinking really hard. I don't know why. Okay. Let's go to my y equals. I'm going to do y1 will be the first one. So I'm going to do 1 plus x plus e to the x squared minus 2x. A lot going on there in that one. And then I'm going to let y2 be the x to the 4th. Minus 6.5 x squared plus 6x plus 2. Now, it's going to graph the f of x one in blue, so I'm going to underline that in blue so that I know. And then it's going to do the y2 one in red. I have pink, close enough. So then that way I'll know which one's which. So before I just hit zoom 6, I actually want to go to my window here because I know, look at my window right here. I'm going to go from 0 to out to about 2. So for my x minimum at 0, I'm going to go a little bit beyond 2 here just so I can see what's going on just a little bit after it. So out to like 3. My y min, again, I'm at 0. I'm going to go all the way up to, it says 4. I'll just go 1 beyond it so that I can pretty much try to grab this exact picture on my calculator. So let's go ahead and graph it. All right, so it looks like this first one right here is blue, so I'm going to do that right there. So that's blue. And this one is red. Like I said, pretty much our calculator is going to match exactly what we have here. Okay? So to go ahead and find the area of the regions, well, I'm going to have R. Let's find the area of R. R is going to be integral. I'll worry about the bounds in just a second, but it's going to be pink minus blue. I don't have to write out the entire pink. I can just say it's going to be g of x minus blue, which is going to be f of x dx. Okay? And I need to figure out what the heck the bounds are. So they're going to intersect here at 0, it looks like. And then we're going to intersect again right here. I do not know what that intersection is. Okay, so what I'm going to do here is I'm going to find out what that intersection is by using my handy-dandy calculator. So there's an intersect function on your calculator. Go second calc, you go down to intersect. All you need to do is there's a couple intersections. There's one right here, one right there, and those are already labeled, so I don't need to worry about those. Those are already labeled for me, those intersections. I do need to figure out this one, though, so I'm just going to just hover my little bugger guy right there, right near it, and you're going to answer the 3 questions. First curve is blue, yes. Second curve is the red one, yes. Guess where it is? Close enough, right? So we're going to get that intersection is going to be at about I'm going to call this letter A, because that way I don't have to keep writing this over and over again. This is going to intersect at A, and I'm going to say that A is 1.032 ... That just means that, yeah, there's more going on. Okay, so to actually make this true for letter A, if I go to second quit, if I take the X value, which by the way will spit out the exact thing I just did. If I hit the store button down here, this little store, and if I hit alpha A, it's going to store it in A now. So every time I hit alpha A, boom, it produces that number. Okay? So I'm going to go from 0 to A. So I'm going to find out this exact answer right here for R. So I'm going to integrate. So second F2, I'm going to integrate from 0 to letter A of g of x, which was my y2, because that's the second one I graphed. So it's going to be, if I hit alpha F4, I can pull down y2. So it's y2 minus alpha F4 y1 of x. And kablamo, that will give me an answer of 0.997, and there's more to that. That's R. Let's go ahead and find S. S is going to integrate from A all the way until 2. And this time, blue's on top. So this is going to be f of x minus g of x dx. So I'm really going to do almost the exact same thing, just with a couple little pieces a little bit different. So I'm going to go from this time A until 2. And I'm going to go y1, because f is y1, minus y2 with respect to x. And then kablamo, this is going to give me like 1.006, and there's more right there. Okay? Add these two up. I'm just going to go in my calculator and just pull them up. So that plus, I can go up, pull it up again, plus that, boom. So R plus S is equal to 2.004. Make sure you run it in the nearest thousandths. And there you go. So that is part A. Now, if our grading part A, for free response, you're going to get 1 point for these guys right here for your limits from 0 to A and then from A to 2, and you have to state what A is. You can't just have A chilling and having, the grader has to know what A is, okay? That's 1 point. The other point is going to come from here, the G minus F and the F minus G. So you get a point for each of those, okay? And then the final point is going to come from our handy dandy answer right there. So this is a 4-point problem, which with the use of the calculator, pretty easy. Okay. Question B. S, so we're talking about S now, is the base of solid whose cross-section is perpendicular to the x-axis, which is important to know, and then squares. Find the volume. So for this one, what we're going to do is we have our area. What's our area going to be here? It's going to be squares. What's the formula for a square? Side squared. So what you're going to do here is, well, figure out what S is. S, I don't want to use, maybe use A, maybe just area, because it might confuse you a little bit. These are different A's. So area equals side squared. The side in this case, if I'm looking for region S, it's going to be this guy right here. It's going to be f of x minus g of x. And a lot of this stuff is already done in our calculator in terms of plugging it in. So it's really just setting it up and then plugging it in. So for this one, our volume is going to equal, S, I'm going to make that little, this means side, okay? So I know I have an S up here. Sorry. So this is side equals, I don't want to repeat letters here. Okay, so area is equal to side squared, and the side is this right here. This is for letter S. I'm going to go from A to 2 because those are my bounds, and I'm going to do f of x minus g of x, and that's all going to be squared, and that's going to give me my volume. Okay? Like I said, this is almost all in our calculator. Actually, I'm really just going to be super lazy and come up here and just recall it, and then I'm just going to just insert some extra parentheses. So insert parentheses there, and one right there, and then square it. And that's exactly, it's written exactly as I have it right here. And then boom, there's my answer. So this is going to equal 1.283. So this was a cross-section problem. Since it was squares, I just need to do the side squared. The side would be f of x minus g of x. And I already determined all that up here. And then I just plug it all in. Okay, if this is being graded, the integrand is worth 2 points. So doing this, f of x minus g of x with the square, that's 2 points. And then the answer is a point. Okay, so here we go. 2 parts. Let's go to our last part right here. So I just left the prompt up here just for convenience. This is all the same wording. So let h be the vertical distance between the graphs of f and g. Let me just go ahead and redo some of this so that we remember which one is which. And then that was pink, and then we had the letter A right here, the intersection A, which is 1.032. I'm just rewriting this because it's your notes, and I just want to make sure everything is super clear. So H is the distance between F and G. Perfect. Okay. At what rate? At what rate is, at which H changes with respect to X when X is 1.8? This is related rates because I'm looking for rates. Okay, so it says H is the distance between F and G. So it's going to be F minus G. Okay? So all I want to do here, actually this is not really that related ratesy. I just need to find dH dx because it wants what rate it changes when x is equal to 1.8. So all I'm going to do is take the derivative of this. So I'm going to do h prime of x is equal to f prime of x minus g prime of x. That's really it. And I'm going to plug in a 1. So it's going to be h prime of 1 equals f prime of 1 minus g prime of 1. This is all we're going to do here. All right, so I thought it was going to be, oh, sorry, not 1. I can't read. 1.8. 0.8. There we go. I'm going to make sure I use the correct x value. So all we're going to do here is take the derivative. Now, what's kind of like super nice is I already have everything typed in my calculator, like this right here. So again, f is the first one, g is the second one. So all I'm going to do here is just take the do the derivative. Sorry, pull up the derivative, which is going to be the third choice, with respect to x, of y1 minus y2, and this is at 1.8, and it really does the business for us. So this is going to equal negative 3.8117. That's fine with 1, 1. You can go 1, 2, doesn't really matter, but that is our answer. So this seemed like a complicated problem, but I guess once we started to understand what it's really asking for, so we just saw what h was, and it wants the rate of change of h. It's just finding h prime. dh dx is just h prime. So we just took the derivative of it, plugged in 1.8. We have a use of our calculator, so it's pretty gosh darn convenient. All right, so for this one being graded, you have to consider h prime. So this would be a point right here, just considering h prime in some sorts. And then the answer, that's the point. So it gives us our 9 total points here for our first month. So there you go. There's the stuff we've been working on with a little bit of old stuff in a free response question.